Hello. So I was asked this question about choose the table and graph of y equals x squared plus 2x. First of all, let's talk about what these words mean. Table, specifically when we're asked the table, they're asking us for something like this. And when they ask for a graph, they're asking for a drawing of some sort. Now, the key things to keep in mind right here when looking at a graph. This polynomial is degree 2. Now I'm using these fancy words, but this also, you can also say this function is of degree 2, meaning that the graph is going to look something like a U shape. Whether it's positive, whether it's negative, that all depends on the number in front, right? But you know it's going to look like a U. Now, let's talk about some characteristics of this polynomial. In this case, it's binomial because there's only two terms. So this one has y-intercept. All polynomials have y-intercepts. Not all polynomials have x-intercepts. They can have, this equation can have at most two because of the fundamental theorem of algebra, but it can have one and it can also have zero. How do you figure out what they are? So before we go into the graph, I want to look at the table because we need to evaluate. Do you remember that word? The word evaluate means to substitute or find the y value given a certain x value. Evaluate. Right? So we're going to evaluate this function. We're going to find out what this is equal to given, let's do the first one. Let's do x equals 0. That's always a good one you want to start with. When x is 0, you plug it in here 0, you plug in there 0, and what do you get? You get y is equal to 0. Boom. That's the first one. Great start. Now let's plug in, for example, let's plug in 1. Let's do an easy one. Plug in 1. If plug in 1, here you get 1 squared. Here you get plus 2 times 1, which is just 2. And 1 plus 2, you get 3. Great move. But now we keep going, and you might wonder, do I just start putting in numbers endlessly? Do I start going like this? What do I do? This is a great start. 0 and 1 are a great start. But now to find out which ones you should be putting on, what you need to do is realize that this right here, this function is factorable, meaning this term and the second term, the first term and the second term have something in common, right? They have a factor in common. Here the factors are x times x. Why? Because x squared is the same thing as x times x. Here you have 2, the factors are 2 and x. Why? Because 2x is the same thing as 2 times x. Now, what do they have in common? What's the one factor that they have in common? They both have an x. Boom. They both have an x. Both the first term and the second term both have an x. So if they share that in common, there's something called factoring out the common factor, right? Find the common factor. And you take out a factor from both of these. Now, when you take it out, which is the opposite of distributing, when you factor out an x, you're left with here, since you took this one out, now you're left with here just x. And here, since you took this out, now you're just left with plus 2. So here are the two things that, here's the x that you factored out, and here's what you're left over. Now, in this case, now you're left with a wonderful situation because there is this theory that you have to master as a algebraic, as a student, is a times b equals 0. That's such a big concept because it works for so many things. Now, um, let me explain that in a bit. Let me just go over it real quick. A times b equals 0. Let me talk about why this is so important. But before I talk about why it's so important, let me talk about other things that are not important. For example, a times b equals 2. Why is this not important? I say this is not important because there are so many ways, infinitely many ways to get a times b equals 2. For example, a can be 8, and then b can be 1/4. A can be 4, and then b can be 1/2. There's so many ways that you can get to. So many ways, so many ways, so many ways. And because of that, there's no way that this statement right here can help you solve what A or what B is going to be. However, this statement has only one truth. The truth is A, either A equals 0 or B equals 0. Okay, that's a big concept. That's a big concept that we need to master. Either A is 0 or B is 0. If that is true, then A can be anything. For example, let's just say any A, 19. If A is 19, if you're saying A is 19, then A times B, in order for it to be 0, what does B have to be? B has to be 0. It just has to be. Or say you made up some B. Say you made up a different B. Say you made up like B is negative 35 over 8, right? Make some random number up, right? Well, what does A have to be? A has to be 0 in order for this the whole A times B be 0, right? Equals 0. So this concept is how we talk about this part right here, because now we have a, which in this case is x, and we have a b, which in this case is this whole binomial. So if that is true, then either this first part, either x is 0, or x plus 2 is 0. X plus 2 is 0. One of those two has to be true. Now, if the first one is true, boom, x being 0 is one of the ones that we want. Here's another one that we want. X equals negative 2. How do I get negative 2? Well, to get rid of the term, remember the only things that you can do to get rid of terms are either add or subtract. That's an important concept también. Make sure to write that one down. To get rid of terms, you either add or subtract. So we want to get rid of this term. So how do we get rid of it? We subtract 2 to both sides, right? So that's how we get x equals 2. So the next one that we want to add is negative 2. That's an important one. Now, since we already know that the answer is going to be 0, we're going to put 0 here. How? How is it 0? Pause. It's 0 because if I were to plug in negative 2 here, if I were to plug in negative 2, negative 2 plus 2, you get 0, and 0 times anything is 0. Boom. Negative 2 is a good one. And because there's no coefficients right here, you know that, the leading coefficient is 1. You know that you want to get numbers near negative 2. So the next numbers to try out near negative 2 are like negative 1, for example. Negative 1 is a great choice. Let's plug in negative 1. What would happen if we plug in negative 1? Negative 1. We plug in negative 1 into this equation. We get negative 1 squared plus 2 times negative 1. Now, 2 times negative 1 is negative 2. Negative 2 and plus, plus positive 1, because the negative 1 squared is positive. You get negative 1. Boom. So there you go. Now you get a good table that's already showing you um, the x and y values. Now, say, for example, your problem gave you like different numbers. Say they gave you special numbers like, I don't know, negative 4 or I don't know, so, positive 13, right? Say they gave you like special ones. They didn't give you like pretty ones or good looking numbers. They gave you these. What you have to do, what you have to figure out is like plug in these x values, evaluate this function, evaluate this function right here, this one right here. Evaluate this function given the x values. What does that mean? Plug in the x's. Plug in the x's into the function and see if it gives you the y's. If it is giving you the correct ones, then boom, that is the correct table. You have the table, okay? Now, let's talk about the graph. So, your graphs may look differently, okay? You may have something like this, something as nice, something as good looking like that, or you can have something completely ridiculous, right? However, let's plug in the numbers that we do know. Here, this function, that's in standard form, or how other people like to call it, they have a different way of calling this. Standard form sometimes maybe vertex form, depending on the school that you're at. Here, for us in high school, standard form was when you have A, B, and C, right? And here we have no C. C equals 0. So if C equals 0 and we plug in here Y, um, hmm, let me pause. Let me explain what I'm doing. Okay, let me go. I'm going kind of fast. Um, a graph, a polynomial has a couple things. Number one, it has the lowest point. Number two, it has a y-intercept. And number three, it may or may not have x-intercepts. So those are the four things that you're going to look for when doing a graph. You're going to look for the vertex, which is the lowest point, or the highest point, right? It could be like something, a parabola facing down, so it could be the highest point. We call those max or mins. And then we got to look for the y-intercept, and then we got to look for the x-intercepts, if it has them, right? Okay, let me go back. Let me erase a couple things. So let's start off with the y-intercept. When I say y-intercept, when we're touching this line right here, when we're touching that line, x has to be 0. X cannot be like, x cannot be 8, x cannot be like 5, x cannot be 1, x cannot be a half. It has to be, x has to be 0. Remember that? So what happens when you plug in x equals 0? Oh, we already know. When you plug in x equals 0, y equals 0. So our y-intercept, boom. Ya tenemos the first dot. We have the first dot right there. Boom. Right? That's the first point on this graph. Now, let's talk about, so we said x equals 0. Ooh, another one right here. -2. -2, when you plug in -2, we get 0. So where's -2? Right here. -1, -2. Let me actually change the the bound so that it doesn't look so kind of like close by. So here's -1 and here's -2. Of course, you can change your bounds to be like a little different. I did this so that like you can see the development, right? So I don't know the y's how they're gonna look, but I bet let's continue. So -2. There you go. Now, here's a couple things that you should know. X-intercepts. X-intercepts, what they do, they help you also find the vertex. The vertex is the lowest point, as I mentioned, the lowest point on the graph, meaning like if you were to keep going down, what's gonna end up happening is you're gonna get the lowest point, right? Because the line, the axis of symmetry, what it does is whatever's on this side is being mirrored with whatever's on that side on the graph. So your graph is going to look something like this. I don't know how it's going to look like. I don't know what the lowest point is, but it's going to look like something like that. Now, every side is going to be mirrored because of this line, okay? But we actually do know that -1 is -1. So here, -1, here we get another point. Let's try this with red, just to kind of like keep consistency. Boom, there you go. So now we kind of have a vision about what our parabola is going to look like. It's going to look like a U, and it's going to be facing up. Why up? Why up? Great question. It's up because here there's an imaginary positive number. There's an imaginary positive 1. If it were, for example, negative, let's say it's negative, then you would be facing down, right? The vertex would be probably up here, but you would be facing down. So there you go. So it looks something like that, right? We know that 1 is going to reach 3. 1 comma 3 right here. 1 comma 3. Where's 1? Right here. 1, 2, and then say up here is 3. 1 comma 3. Boom. Right? So then there you go. Now you kind of like drawn, and it has to mirror. So like this, for example, if this would keep going, it would be mirrored. Okay? So recap everything. Number one is when they're asking you for a table, if they already give you like X values, find out what those Y values are. Okay? Graph. If they're asking for a graph, you need to find out some crucial things. You need to find out, number one, where is your vertex, right? And you can find the vertex given either x-intercepts or you can find it, with the y-intercept también. Pero the best way to find the vertex is to factor. In this case, you want to factor. You find out the the x-intercepts. Here's another way. I know that when I was at El Camino, they told me that vertex form is actually the standard form. In other words, here's like a whole separate concept. So really, like, you don't have to worry about this. But well, actually, maybe you might learn it in class. What you're doing is you're finding half of the b, and you're squaring it. half of 2 is 1. 1 squared is 1. So what I'm going to do is I'm going to add 0. Instead of adding 1, I'm going to add 0 plus 1 minus 1. I technically added 0. I didn't change the function. This right here in blue is 0. So I don't really change the function. Technically, you can add 0 to anything. If you have 3x plus 5 plus 0, then nothing happens to the equation, to the original equation, right? Because 0, that's what it does. That's the point of 0. But now, here in this case, x squared plus 1, let me write it over here. I had x squared plus 2x plus 1 minus 1. What ends up happening in this case, now what we've done is we've completed the square, meaning these first three terms can be simplified to x plus 2. And if you have any more questions on completing the square, please look up videos that say complete the square. And here you're left with minus 1. So, oops, I messed up. I made a mistake. I made a mistake right here. It should not be 2. Wrong. What it should be is half of this. Half of 2. Half of that number. Half of that number is 1. Okay? So this right here, once you made your equation look like this will help you find the vertex. How? The vertex is uh technically negative h comma 0, which in this case was negative 1 comma negative 1. Where do these numbers come from? The y, that one comes from right here. Boom. That one's going to match always with this one. But this one, the first term, the way it's going to match is if you plug in that x value that will make this equal to 0. Okay, which in this case is negative 1. So negative 1 plus 1 is 0. Okay, so negative 1, and then yeah, you get your x value, you get your y value. Boom. This is your vertex. That is the lowest point. I feel like I didn't really explain that with all the proper mathematical terms. I know people watching this are like, oh, like what are you saying? I'm specifically talking about the vertex. I may need a better explanation for that. That's at a later time. But anyways, so the vertex is helpful, the x-intercepts are helpful, the y-intercept is helpful, and a couple points are helpful. Boom. Now you can match up your graph, your function with the graph. Okay. Evelyn, I hope you're doing great. I know that going to college for the first time may be kind of hard and scary, but you had a question about adulting. Adulting is literally asking questions, asking people like, what do I do? Like, do I take these classes? Do I, how do I build community? Like, is there free tutoring? Is there free math tutoring? I know at USC there was a math center, and then there were certain TAs that would go in there and like help out. So I'm sure other schools have the same thing. And yeah, I think navigate, like, como dice, ponte movida, like kind of like figure out what is available to you and ask. You're never bothered, especially when you're new to these things. Okay, thank you for watching the video. See you later. Bye.